session. My name is Max and I am developer of Roborace Metaverse platform. This week we continued to prepare to Mission 5. Mission 5 was rescheduled and will take place in the middle of the July on the Las Vegas Motor Speedway. The event will be streamed on live on this channel. Don't miss this event. So last time on the last stream we checked if the bugs were fixed, and we faced that some of them wasn't fixed. Since the tests was on the last week on the Thursday, Wednesday and Tuesday, we have lack of time to fix them all, but we worked hard and had a success. But it was not without surprises. We forget to change some properties, and on the first day of test session, in the Tuesday, we faced an issue with a collision detector. It wasn't working, but it wasn't a big fault. Because the main goal of this test session for teams was to run the new track. This track was the teams has never been run on this track, and they need at the main goal to test performance of the car on the new track. Because this track allows teams to and DevBot generally achieve speed more than 200 kilometers per hour. As far as I know, the maximum speed achieved by teams at the moment is 117 kilometers per hour. So 200 kilometers per hour is very fast for fully autonomous racing, and this speed haven't achieved yet on the real track, but teams can easily achieve speed more than 200 kilometers per hour in the simulation environment. And despite of upcoming Mission 5, bug fixing issues and testing, we are continue to develop new features. And at the moment, we are developing new functionality related to using road maps of the next generation, high definition road maps. And at this week we release it for internal tests, the new service that has an ability to use new map format for autonomous racing. And at this stream I wanna test this new service in the Metaverse platform, integrated to the Metaverse platform. And let me share my screen and let's go on. Yeah. Okay. So let's talk a little bit more. Yeah, okay, so some issue with my mic. Okay, so let's talk a little bit more about the maps. Why maps so important for the autonomous driving? And high definition maps is very important for autonomous driving, because there are many pieces in the autonomous driving puzzle, and one of them is the high definition maps. Why autonomous driving needs such maps? autonomous driving system needs such maps to understand the precise position, play beyond sensor visibility, process contextual awareness of its environment, and have local knowledge of the road rules. And actually, on the Metaverse platform, on the previous missions, we have missions on different tracks, and these tracks are listed on the management tab of Metaverse Control Center. We can check them and to see. This is the Anglesey track. As I remember, we had first mission on this track, or maybe second. Truxton. It is Anglesey in Truxton is in England. Yeah. And what else? Bedford. Mission 3 was in Bedford, as I remember. Yeah. And the main purpose of maps for autonomous driving is provide the road network description that can be fed into simulation, into the simulators, to develop and validate performance of ADS driver, its safety and its performance. Yeah, such map like this can be placed to the simulation environment and can be used by ADS to refine ADS algorithms in the simulation environment. And it's very important that that map should provide information about road network. Okay, cool. And as you have noticed, at the moment for Roborace, we are using very simple maps. It's just one road. It is circuit. Las Vegas mixed variant also is the circuit. And the format of this map is pretty easy. It has only 3 lines and zones. So one line is the center line, and other ones is inside and outside borders. The map is represented as an array of points that are obtained by GNSS sensor, by high precision GNSS sensor. Yet it is just an array of points. It is not arch or maybe spline or some geometric function that allows to define map in high definitively. Yeah. So, and this map is tracked by trackside engineers. He plays the GNSS sensor, this high precision GNSS sensor, to its backpack. On this channel we have the video how this process look like. He drives the scooter and drives along the borders, and GNSS sensor collect the data, high precision data. And when these 2 lines inside and outside is obtained, we can mathematically calculate the center line. It is just in the middle between inside and outside. Yeah, and this map is used on all components of our platform. On ADS software, you can see representation of this map also in the Metaverse Control Center. And this map also is used by Mission Logic by mission logic to calculate competition results, to decide whether the achievement maybe overtakes, and to decide when the devbot should be aware about upcoming gizmo. It is also calculated using this map. And this map has a lot of limits for us because it is very simple. This map not contains any information about road network, and that's why, according to the mission plan, we apply support for map format that corresponds to these requirements. We did several attempts to develop our own format, but finally we decided to support industry relevant road network format that's called OpenDRIVE. So yeah, let's go on, and let me show the editor. That is an open source editor, OpenDRIVE designer, and here we can see the background of IRL image obtained from the satellite, and here we can, using this image, create the road network using tools that are presented on the toolbar. And finally, this road looks same. Yeah, this is the 3D viewer with the representation of the OpenDRIVE map. So what is the OpenDRIVE map? This format is the standardized format, industry relevant format, and it is supported by ASAM. The ASAM OpenDRIVE format provides a common base for describing road networks with extensible road markings. We can mark lanes, we can add some arrows, we can mark junctions of the roads. This road is represented as an XML file and has a very good specification. This format allows to describe the road segment as a function. This is a nudge, for example. When we was using old format, we need the array of the points to describe the road shape in the turns. Yes. And for purpose of to have all cons of this format supported on our service, we need to develop some service that supports this format and that convert GIS data obtained from OXTS sensor located on the OBU, on the devbot, and convert it to road coordinates. This road has road identifier, and usually the position of some object of the map is represented as identifier of the road. You can see it in the left bottom corner, and S and T values, where S is the distance from the 0 point of the segment, from the start of the segment, and T is orthogonal distance to the object on the road. On the center line it is just 0, and it can be more or less than 0 when it is on some side of the center line. And yeah, we have developed the service for internal tests, and let's test it. For tests I need the source of GIS data. It will be an arrival simulator. Let's launch it. Yeah, the Hive simulator is already configured for Vegas mixed variant, and I need to change some YAMLs to support the track on the Hive, and that's why I will use for this simple test another sim that we were used before, because I just need the coordinate of the ABU, the simulated GNSS sensor. Yeah. And let's open our track. Let me find it. It was somewhere in the history. No. I have a link with the road points with the roads. So to support driving from the pits to the start-finish line, and to support drive on the mission competition, we need at least 2 tracks. Okay, sorry, let me find the link. It will take maybe a minute. Guy from our team sent it to me yesterday. Okay, and let's open. Yeah, here it is. Okay, this is the Las Vegas Motor Speedway North variant, and as you can see, it consists not only the track on which the competition is performed. It also has technical road from the garage to the pits, and from the pits to the start-finish line. And actually, our very simple format doesn't support these roads, and that's why we implemented this service. just compare it and this. Okay, let's test in the simulator. I will place the simulator in the left corner, the metaverse platform here. Yes, and it will be also useful, this window, where it is. Okay, yes, okay, and I need to see logs output of the new service. Yes. Okay, let's restart it. And what I expect? I expect that new service will read GIS data from the special topic of the Kafka, from the data bus, and converts latitude and longitude to the road coordinates. Looks like some freezes. Let's restart the idea. Okay, just kill. Terminate. Okay. Let me open new service. It's called just OpenDRIVE service. It's is written on the Java, and here we implemented algorithms that calculates road position or road relative position of the incoming signal. This is just an OBU signal at the moment, but road relative position can be calculated for each object represented in the metaverse. This object should have only geo coordinates, latitude, longitude, and altitude. Let's start it. Yeah. So what we can see here, we can see I logged to the terminal the road relative position of the OBU on the track, and here we can see that the position is defined for two roads, for tech road and for the track road. The car stays on the same place, and we need to drive it and to look how the position is changed, the calculation. Okay, let's drive it, and we can see that S coordinate is changed. Let's see on it a little bit more closer. The most interesting point for me is the point where the final and finish position of the road at the same time. It is somewhere near to to the first point of the track segment, and it is here, I guess. Yeah. Let's move forward. As you can see, we have 1071 meters. Let's move forward, and the most interesting place for me is the place where the S should become 0 or maybe 1. Yeah, this is this place, and let's compare with the roads. Unfortunately, we do not have the OBU marker and track points, road points on the same map, and it is difficult for proper test to compare. And on this map we do not have layers. But yeah, it looks like at the same place. I want to do the whole lap and to watch the S coordinate of the road, of the track road. I expect that it should increase in properly way without any gaps, and it always should increase the S coordinate. Yeah, and what happened? We saw a very interesting point. Let's move back to this point. Yeah, this point. This point is a junction of tech road and the track road. And what we can see as the property, we have the range. The property of this application, we have the range in which забыл слово принадлежность, in which should be decided to which track the actual GIS coordinate belong. And when we was on this part of the track, we have position for 2 roads, because let me open the map, because on this road segment, we have it is mutual for 2 roads, for the tech road and for the track road, and this service allows us to calculate road position of the dev bot, not only for the one track, but for all tracks in the range that we specified. It's very cool functionality. And here on the Google Maps, you can see this point. Here it is. And when we passed this point, we have only one road, the track road. So this service allows us to define position of the dev bot on the several tracks, on the several roads. Let's do a lap. Yeah, looks like T and S is changed correctly. Let's switch to the Metaverse Control Center. Where is our devbot? It's here. I want to do the whole lap, and I think it is enough for testing. this road, the track road. Okay, cool. Looks like it works correctly. We didn't face it any gaps and some weird behavior in S, T and road name calculation. Let's test another road, tech road. Where is points? The first point. Okay, and where is the second? Okay. Initial position here. Let's go to the initial position. Okay, the service looks like the service cannot calculate the position because we are on the wrong way. Let's compare. And zoom out. Yes. Yeah, we are on the track and we can see in the terminal the information about track road position. Oh, I missed a turn. It's not a big problem. Because we are not on the Moscow circuit road. In the Moscow it is a fatal when you miss the turn. Looks like I am on the wrong road. Let's compare again. It is not comfortable to switch between maps. Yeah, some double map with a little parking area between them. Let's find it on the map. Looks like this one. Yep. No. Yes. Okay, S is 0. We are on the first point of the technical road. And let's drive through this road and check. Again. Why it's not calculated? Okay. We are driving through the tech road. This service, this new service, will be used by all components of Metaverse platform that are interested in the maps, and I think that soon we will present to the teams that they should support a new format. I think that when teams support this format on the ADS, it will be a big jump in the development, because we are driving, as I said, on very simple map that not provides any information about road network. And at the moment, the safety driver moves manually in the human drive mode to the start finish position. I think that and that is our plan, that the DevBot should fully autonomously go to the start finish position from the garage to the pits, and from the pits to the start finish position. All mission should be fully autonomous. And yes, we can see the road here. No, why? Oh, yeah, this is the same as it. Don't miss the turn. Where is the turn? Next. I wanna turn to the technical road here. Looking on the position, S&T calculated properly. But yeah, when support of the OpenDRIVE will be provided on all our services, it will be easier to test it. Maybe it has some mistakes, but we didn't face any of them. It works as we expected, and yeah, currently we can deploy this service to the testing environment, and we can switch all our other components for the new map format. And for the future missions, it can be more complex configuration of the road networks. Yeah, it's really very cool that we can calculate position on the different roads on the map, and mission logic can be extended when we have such information. Okay. Nice. Yeah. Sometimes I like just to fly on the simulator on the track, and also simulator can be used for teams who provides representation, mixed reality, to choose better position for the cameras. It's really very cool and very helpful for us to configure all environment of upcoming mission in the virtual environment. So okay, I think it's enough for testing today. The service works as we expect from it, and we can enrich this service with more extended API that will provide us to calculate some more features. We can calculate the roads between points, we can calculate the distance from the current position of the DevBot to the final position of the mission. And a very important thing that this map allows us to configure competition not only on the circuit roads. When we have support of this map on all components of our system, we can configure very complex configuration of the roads. It can be several streets in the city or something like that. Okay, cool. It's working. Please thumbs up, and do not forget to subscribe to this channel not to miss new metaverse tech sessions. It will be more interesting things, and the mission 5 will take place in the middle of July. It was rescheduled, and subscribe to this channel. Don't miss this event. It will be very interesting. New gizmos, new competitions, new performance, new speeds. Thumb ups and goodbye.
It's the underground of motorsports. First, we challenge the idea of having human drive.